Alright, for our next section, we're going to get into the vertebral column, so we're working our way down. For this one, we're going to focus on talking about the different regions of the vertebral column, the number of bones we find in each region, and then the typical vertebra, so what are the features that all vertebrae share, and then what are some of the ways we can distinguish vertebra from the different regions. We'll also talk about the sacrum and the coccyx, as well as the intervertebral disc, and some of the ligaments that provide support for the vertebral column. So the vertebral column is also called the spinal column, or the spine for short. It's a sequence of 33 vertebrae separated by intervertebral discs. And the whole function of the vertebral column is to support the head, neck, and body and allow for movements of those body parts. It also serves to protect the spinal cord from, as it exits the skull all the way down the back. So let's take a look at the vertebral column. We're going to talk about some of the regions here. So we have cervical, thoracic, lumbar vertebra, and then down at the sacrum and the coccyx, these are vertebrae that have been fused together. We'll get into detail when we get to those, but let's talk about the three main regions first, which is cervical, thoracic, and lumbar. The cervical vertebra, these are the vertebrae that make up the neck, so we find them in that neck region. You have 7 of them, and they are named C1 through C7 to form that cervical curvature, right? So the neck curves so that the dip of the curve is facing anterior, and then we'll connect to the thoracic vertebra next. So the 7 cervical vertebra, C1 through C7, then we get to our thoracic vertebra, of which we have 12. These ones are named T1 through T12. So you'll notice the theme here of how we name the vertebra. These are going to form the thoracic curve, which is curving back, right, posteriorly. And then we get down to towards the bottom, the lower back area, we have the 5 lumbar vertebrae that are going to curve forward again to form the lumbar curve. So you notice we have like this S-shaped curve in the spine. This S-shaped curve is just how we kind of jury-rigged ourselves together after becoming an upright species. And then, like I said, down at the bottom we have the sacrum and the coccyx. These are going to give the sacrococcygeal curve, so basically the back curve of your pelvis, and they're fused together. In between all these vertebrae too are also the intervertebral discs. So let's go ahead and talk about the general structure of a vertebra. So this is just like, in general, what do all vertebrae have when we're looking at them, regardless if they are cervical, thoracic, or lumbar. All of our vertebrae are going to have what's called a body. Right, so here's the body from the anterior view. This is from the superior view. Here it is from the side. We have an opening that is going to be for the spinal cord to go through, so we call it the vertebral foramen. We have 2 different areas where we can potentially connect with ribs if we're a thoracic vertebra, which we'll talk about when we get there, but we also have to connect to the other vertebra. So we have like the superior articular process up on the top. That's going to be the part that sticks out to connect to the vertebra that comes above it. And then there's also an inferior articular process that is going to be used to connect to the vertebra below it. We have a pedicle, this is one on each side, which is then going to lead us to the transverse process, and there's a transverse process on each side as well. And then at the very back, we have the spinous process. So if you think about what you feel, if you were to run your fingers down someone's back to feel their vertebra, you would most likely be feeling their spinous process. So, like I said, these are things that all vertebrae have no matter what. Now, how big things are, what shape they are, if they extend out far, if they're short, all those things, those will vary depending on which region the vertebra is from. So let's talk about the cervical vertebra first. Again, this is C1 through C7, so the first 7 vertebrae that we find in the neck. And so these guys are going to have some slight differences, right, from that typical vertebra. They do have the transverse process and spinous process, but if you notice, they're bifurcated, meaning they're forked, right? So that's something that is unique to the cervical vertebra. You can use that to identify a vertebra as being from the cervical region. We also have this transverse foramen as well. So those are things that you notice. Also, the body tends to be very small. The vertebra in general tends to be very small, but the body is definitely smaller than the rest. But again, this is the key. This bifurcated spinous process. You see that, you know exactly what region you're looking at. Now, this is for C3 through C7, but C1 and 2 are even more unique than that. C1 and C2 are also called the atlas and the axis, and so this is going to be like where your skull's like connecting to your spine. And these are the first two that really give the most range of motion for you to be able to turn your head. Let's go ahead and look at the atlas first. So the atlas, we notice that we really don't see a spinous process, right? There really isn't one poking out. We don't see a body either. It's relatively flat. It's relatively flat. This transverse ligament will not be there if you look at it in the bone boxes in class, but it's very different, right? Instead of having like a spinous process and everything, we have what's called a posterior arch. Now, this is C1. The atlas is C1. Just underneath that is C2, the axis, and this one's unique, right? We do see a spinous process. We do see the transverse processes, even though they're small. But the major thing is this dens. This dens right here, if we're looking at it from the back, actually sticks up, and it's actually going to hook in to C1. So we can kind of see it here, right? We see that dens actually hooks up into the C1 vertebra. And so again, this is going to be what's going to help contribute to a lot of the range of motion you have in your neck with being able to turn your head around. You should be able to identify the atlas and axis specifically because they are so unique, right? Those two there, you should be able to identify specifically. Now, C3 through C7, I will not expect you to be able to tell me which number they are. If it's C3 through C7, you can just say cervical vertebra. But for C1 and C2, the atlas and the axis, they are very specific. They're extremely unique. And so those ones, you should be able to identify exactly which vertebra they are. Moving down to the thoracic vertebra, these ones are going to be, we have 12 of them. And if you think about it, we have 12 thoracic vertebrae. We also have 12 pairs of ribs. So that's going to be the major thing here, is that we are going to articulate with ribs. And so we have additional facets, right, to articulate with a rib. So we see, like in this case, the articular facet for the tubercle of the rib, right? We see that there. And when we see the ribs, we go into that one, we'll talk more about how they articulate. We'll actually see the ribs connect. But there's these extra things for the ribs to connect to on these. One of the other big things too with the thoracic vertebra is this spinous process gets very long in comparison and starts to have a downward slope, right? So we see a much larger and more downward slope in that spinous process. But again, the biggest one is we have these facets for the rib articulations. So here's how that rib connects, right? So we have our articular facet for the tubercle of the rib right here, and then we also have where the head of the rib is going to articulate, right? So if you see those, right, that's going to be your key, right? This here, you see those, you know, that's your key for, hey, this is how a this is where a rib would articulate. Moving down, we get to the lumbar vertebra. The lumbar vertebra are much larger, so you can think lumbar is large. The body specifically is very large compared to the rest of them. And the transverse and the spinous processes, they're still there. They're kind of wider and shorter though. So if you notice, like, it's gotten wider, but it's gotten a lot shorter. So the spinous process doesn't extend out super far. It's not super long like some of those thoracic vertebrae, but it's kind of like a wider, shorter, fatter spinous process. So you can use those to identify them as well. all the way down at the bottom, we have the sacrum and the coccyx. So the sacrum and the coccyx again, these are fused vertebrae. You can actually see kind of the remnants of how they got fused together. So if we look at the sacrum here, we see that there are what these things called transverse ridges, and that's where the vertebrae have fused together. So this would have been the bodies, where I'm circling with my mouse, would have been the bodies of the vertebra. And then the transverse ridges, that's where you would have had an intervertebral disc, but instead it is fused together into one solid piece. Because we fused together, we still do have some holes. These are the sacral foramina, so the sacral holes. And we see them on both the anterior and the posterior side. And so they're named just for which direction it's facing when you're looking at it. We have the sacral promontory, that's going to be where the lumbar region connects to the sacrum. On the back side, we have the median sacral crest. So think this is going to be what's left over from those spinous processes, right? So it's kind of like the equivalent there. And the lateral sacral crest, that would be the equivalent of the transverse processes that we saw on the vertebrae that were still separated out. So they're kind of equivalent to each other there. We have the auricular surface. We also have the facet for the superior articular process, so we can connect with those lumbar vertebra. Down at the bottom, we have the coccyx, so it's going to connect at the apex, right, which is like a point. So the coccyx connects to the sacrum's apex. It's about 3 to 5 little bones that have fused together. This is also known as the tailbone. The intervertebral discs are the discs that we see between the vertebrae. This is going to be made of cartilage, mainly fibrocartilage, and this is to provide shock absorbance as well as protection against friction between the vertebrae. And so if we look at the intervertebral disc, there's two main parts. We have the annulus fibrosus, which is the outer section of the intervertebral disc, and then the nucleus pulposus is going to be the inside, that middle section there. And if you think about it, nucleus, right, sounds like it's a nucleus, like of a cell, would be on the inside. So maybe that helps you remember. But the bones alone cannot necessarily function in support without a little bit of help from the ligaments. Remember, ligaments connect bone to bone. So we have lots of different ligaments that are going to be running the length of the vertebral column to provide that support and structure. One of those is going to be the nuchal ligament. This is going to be connecting along this line back here on the occipital bone, namely on this area called the external occipital protuberance, little section that sticks out. We have the supraspinous ligament. So this is the ligament that is over the top of the spinous processes. And then the anterior longitudinal ligament, this is going to be the ligament that runs along the anterior side or the front of the spinal column.